Time for another tutorial. So, lately I've been going over some stuff and I made a UFC fighter prediction using machine learning in R and Python. So, let's go to what I did. Okay, so, so these are all the files. And then, originally what happened was I used some video files that I had um, basically taken from ESPN streaming of some fights involving Amanda Nunez with Tate and Rusi and Pennington. But I had also done this with other fighters. So I had also taken the Masvidal and Till fight, and I took uh, an action record of all of the hits landed, missed, and received by the fighters in that. And the ones in the Nunez fight, only for the first 5 minutes or until Nunez knocked them out. And it was only 3 fights for Nunez and Masvidal. It was just with Till, and then also with Diaz for his fight with Pettis. And I had also done some earlier with some smaller venues that were like pre-loan fights. Um, okay, so without avoiding copyright issues, I basically just opened up one of these slides and made a note of all the actions. So I made an Excel file and I named it Sarah Eaton by Wolf because I believe I had a hacker in my um, virtual Microsoft Office that did not like Nunez. And every time I saved it, it would erase like hours of this work that I did. So this is what happened. So I have like fighter X1 is Nunez, fighter X2 is her competitor, and then in the notes I would have who it was she fought. This was Kate, and it was only the second that she actually there was some action because anything that wasn't action or it would just continue to change like on the ground wrestling or just dancing in the cage, sidestepping. It had the round. It also had time, the time right here. So that's one instance, in this instance. And then it would have the note, misses right kick, so nothing went on, but that is in action, everything else is deleted. And then you go down, Pennington, this is just the first, the 5 minutes, because that lasted all. And then Rusi is at the end of this one. This one didn't last very long. And so I took that together and I actually automated so that it could take out every way that I would put land, missed, or received first, and then I would put the action. So this is a left jab, and then this is a miss for the X2, which is in this case Rusi. X1 is Nunez for this one. And opening up the script, I automated in R. Something I'm doing. This is the simulation, but we'll open the Sarah Wolf eating. Story about this is I had a chihuahua named Sarah, and her original name was Hannah, and she talked to some big dogs late at night. She got out of the fence, and they ended up being coyotes. But in memory of little Sarah, poor little Sarah, just such a sweet little, such a good little guardian. I just some dogs they just have that little Napoleonitis thing. It just so this is the previous script. It's actually not the one I wanted to open, but just to show you what. Okay, We are in the right directory, but I'm going to open up the script that I need to open up. I believe it's under terrible. Okay, so, mm, all right, so this is the script. The directory. So I would take out of those notes where you see it starts with land, there's a jab. There's also another sequence in there, comma right here. So I would take the first sequence, second sequence, and some of these instances for 1 second have 3 sequences or 2 because it doesn't just go 1 second, look jab, 1 second, right cross or whatever. So this is what this is what I meant just from what I see on that. So a kick, front kick or Muay Thai kick, elbow, starts with an elbow. This is the land. They land it. I use some grep commands for extracting character strings. Upper, there's an uppercut. There were some hooks with the left. There were some right crosses, maybe even some left overhead crosses. Some takedowns. A hammer when they're on the ground, strikes with the hammer. Those are usually multiple hammers in one instance. And then you have the mist. And the sequence right here is sequence 1. That's the first of the second hit. And then you have it for, it goes for sequence 2. And it goes through this entire list of notes once the, this one right here, this command right here actually removes not equal to 0 or not equal to 0. So whenever there's a miss that nobody gets anything, if there's a land, then obviously the person got it received. So in the code, when it goes through all the sequences, 2 through 3, and then you populate, it will, and then the sequence B is for X2's land, misses, and received. The received is equal to the lands of X1. So it ends in little r for the received and B for X2. It ends in M for the actions they took that were missed. And then in this final script, it's going to have the added features. So this is the added features, and this is what it produces. As you can see right here, it will end up taking across the cumulative hits, total hits, and then it'll say for X2, X1. This is the target variable right here when we do the machine learning. And I can run this through Python and there's all these hits. Those are all, for every sequence, that's the total for that instance, that second. And we can see a lot of jabs and crosses and the cumulative hits flag. But there is actually 182 of these features right here. And so when we do the machine learning, you will end up having, I went ahead and saved it as an HTML file. It is, okay, yeah, so I took the Mazvidal set that I did the same exact thing with. I named him Wolfie, and you'll see that his is exactly the same. We made sure that variables are the same. Me and my ego, yeah. So you can see all the features are there. And we went ahead and through. This is just how you get the notes into the automated filtering and extracting and finding every sequence of instance of those types of actions, hit actions or reactions. So this type of machine learning actually, those actions and reactions for each instance of cumulative hits landed, missed, or received target area was hits landed by X1. So we have the same format for Mazvidal, and we did a simulation in R. So it simulated machine learning both in Sarah, that's her alias for Nunez, and then the 51st, not the random. In Python, I do the random 50 for Wolfie, which is Masvidal. And so we end up doing this as a markdown file so that it prints out. As you can see, we removed all of the hits landed in X1, and this is the machine learning part, different plots. I want to add an XG one because I just watched that on Kaggle's tutorial, which is free. Feel free to look at that. It adds to my $2,500 course in my master's. We're always learning as data scientists. You do have to have an ego because they will walk right over you. We removed all the X1 landed, X2 received from all those features that you saw here. These X1s, X1, the crosses, the hammers, and then we just left the X2 so that we could use those as feature selections to predict the target variable landed for each instance, given those simulations of cumulative hits landed at that time, seconds gone by since the last action. And this doesn't take into account power or strength, but in this particular one, I used the random forest, the math, the GBM, and the carrot packages to run the algorithms for machine learning that were random forest, our part, which is recursive partitioning trees, ensemble, well, actually it's combined, which is their type of ensemble, and GBM, GLM. I'll give you the access to all of this stuff. If you go to my GitHub, I can just tell you where it's at. Sarah Wolfie. But it's GitHub.com, Jan 2018. And you can run all this stuff yourself. Probably. It's a zip file, so you mess up the wrong thing. And, run it again and do the right thing. And so the file is actually right here. Nunez and Mazvidal. No archive. Yeah, once I had everything already recorded, I uploaded it, and Sarah will feed R. That's the original one. Sarah will feed the features. That's a CSV file. You can open up in Excel and look at everything. There are the markdown files. HTML, it shows you the actual process. And then this doc file right here, sometimes our markdown, if you run it too often, it doesn't let you do HTML, even if you erase the old file. So I just save it as a Word file. And this is simulated, so I use the first Mazvidal as a simulation. Plugged into Nunez's model used on her entire training set of instances to predict, and the accuracy wasn't actually bad. It was actually pretty decent. So open that up, and you can see that Nunez is Wolfen, that's Wolfie, that's Mazvidal. Omit the X1, X2, look at all those features. Those are all the X1 features for the specific actions. Oh, actually, these are the notes also, the notes that you don't need, because that'll ruin the trees sometimes, or the machine learning algorithms. And you'll hear different thoughts, because it's still relatively new to the public and so big and inflated. with data science that people are like, oh, you should know exactly what you're doing when you run an algorithm. And then I just read a book in my course that said, no, actually, you can change it and just plug it into everything depending on the size of your data and see what works best. If there are any errors, then you can go back and fix it. But then you'll hear from people that just refuse to say that because they're in a position where they actually have a paid job and you're not, and so they have to always defend it with a knife and tooth. So I stay away from those people. And you can actually plug in any of your data if it's ready to go. And I believe in this case, GLM actually was not very good at this. It had negative prediction values. Oh, actually, it was in a different one. But the prediction rate is 72%. Actually, 86% is the best, and that one is. This actually will show you the that's our recursive partitioning trees and generalized boosted machines, which are trees. Those are actually the best. And this is actually showing how similar it is for, and these are the predictions. So actually, predicting 0 when it's a true value 0, that counts. So I do believe I show later. So this is how similar it predicts Nunez's trained model on all of her instances when Mazvidal's instances are plugged in as a simulation. This is how similar it predicts her hits landed will be to Masvidal with the best one. This 100, that's just the true value. So there were actually 50 in the simulation because we did use the first 50 in this set. And we're adding some more features. This is the actual hits landed. So this tells a lot because there weren't even that many hits landed. As you can see, there was like 7 out of 50. If you guess 0 the whole time, you're gonna be around 80 to 90% accuracy anyway. So the random forest 14% accuracy. Generalized boosted machine, earlier it was 86%. It's 0% accurate for predicting the actual hits landed to the hits landed, not predicting the hits landed equal to 0 with the hits landed equal to 0. So the best score for the hits that were actually landed was actually generalized linear models and k-nearest neighbor. So this shows the similarity that it predicts Nunez fight reactions actions to and they're both strikers, so that makes sense that they would have the same reactions, similar reactions. We're going to go to the Python one now because there are some different algorithms there, and every algorithm you see, there's literally hundreds of thousands of variations, and the program writers change little things like the way it iterates. I mean, you can change these factors yourself too with the number of cross-validation steps, or when you do gradient boosting or gradient descent for the mean squared error, changing the step and how it generalizes to prediction on the testing set. So let's go to the Python one now. Back to the folder, and we see that I have the IPy notebook. I use Jupyter Notebook, and the Python 9s and Moss. I had to rename it. Nunez is 9s, and I just said Moss because I've already recorded it. So I really need because I can log in from Microsoft Office, and I told someone I was working on this, and somehow every time I saved my Excel file, it got erased. Because you're supposed to back up and save your file, so I just, you know what? Once I changed the name to Sarah Wolfen, it worked. Okay. So, anyways, getting back to the Python. Okay, the 9s and Moz ML simulation. It's the same data set, we just use the added features. This is the results with actually using the random instances of this. Let's see how many, because I had to make it equal to the 30% of Nunez's So she has 49, so I took 49 random samples. This is the the testing set of the 92 instances of Mazvidal. There's actually 92 of his instances. Right here, yeah, because the headers, 92 instances. I did that in R with sample number of vectors, and I copied and pasted the Python. And I get, so we used, this is where I bring in Mazvidal's testing set. I did some more work because I actually had to go in and combine the actual test samples to the prediction. This describes the set. You can see there's 92 samples that were randomly selected. This is where I, okay, yeah, so I had to manually take in all the columns that I used. Some of them weren't used, but they are the same exact fields that were used in R. Okay, so we have Mazvidal's data set. This is the testing sample. Then we have Nunez's. This is the first one of hers. That's what the true hits landed were in the testing set that we try to predict accuracy. And then also this is the Mazvidal. Okay, yeah, so this is where I copied and pasted, but I had to actually add in the comments to this vector of the sample so that it's identically equal to the size of the vector of samples that were 30% sampling test on Nunez. And then in this, I show you how well the models predict the testing set of Nunez's training samples on her testing set and on Mazvidal separately. So we use k-nearest neighbor first, and that's from sklearn, the scikit-learn package. And then predicted on the Nunez testing set, and then the Mazvidal testing set. And then it doesn't take much time at all. These are the values that were predicted. A lot of zeros. Those aren't scaled. So that was just a test within Jupyter Notebook because it's not. It's you can do it like code by code. You don't really see the objects like you do in the R where you would have the objects here if I imported them. I mean, there's other features that do that, like spider targeting. This gives the shape for those predicted samples, which should be the same as the testing set. And this is how I added in the true hits landed for Nunez. This is her true hits landed, which are the actual hits landed in Nunez testing set. 12 out of 49. So if you guess 0 the whole time, you're still gonna get 37 out of 49 samples, which is high accuracy. The Mazvidal true hits landed, and his were 10 out of 49 in those instances. And the accuracy it says right here. So if you guess 0 the whole time out of those testing samples of 49, you would get 80% accuracy. And with Nunez, 76%. Now these are the predicted results for Nunez. And then there's some ones in there. There's one. And this is the predicted with Nunez. This is Nunez's model predicting Maz's samples. So actually, given those simulated events for cumulative hits landed, time since last action, all the hits that were received or missed or landed previously, or in that instance, but not landed, because that's not what you're using. That's what they predict Nunez would have a hit landed. And so the accuracy with k-nearest neighbor is 67% in the Maz test predictions, equal the true Maz hits landed, which means how accurate, how similar Nunez's actions or reactions are to Mazvidal, 7%. And then the instances that the Nunez test prediction equal to Nunez true hits landed, 81%. That's how well the model, using Nunez to train it, is in K-nearest neighbor to her actual test set, which is 81%, 81.6%. And then the instances that Nunez test predictions equal to Maz test predictions this is actually how similar in reality from those test samples that were equal to Maz's test sample, even though there were different instances. This is just a side-by-side comparison. And it's 75.5%. And then the instances that Nunez test predictions equaled Maz's true hits landed is 40, so that's 81.6%. Yeah. Then the next one is looking at the side by side. So we'll go ahead and look at the actual hits that were real and the ones that were predicted for Maz. So you can see it got 2 of them correct right here. That's correct, so that's a different accuracy. We're just concerned with the accuracy of the design. These are the indices that were the hit land, so I can create the table and merge them. And yeah, actually I'll get to the table. I want to go through all the code. And here it is. This is the predicted hits landed, and it could tell you what those simulated actions were seconds into a round, the last action right here, which means it's 20 seconds since the last action, because they could have been walking each other, standing up, or on the ground, not doing anything really that noticeable. And then you have all the cumulative hits for X1, and then which is Nunez, and then the model simulation in this instance. I actually saved it to a CSV, so you'll see that in this folder, Maz test set using Nunez. Maz test set using Nunez, so you can see it out big instead of in the HTML file. And this what instances, and these are the real hits landed as predicted. Going back to this file, there is the Nunez hits predicted and real hits. This is her. It only predicted one, right? So that was her real hits landed, and then the ones right. This is removing all the hits not landed that were predicted correctly. 0 in the instant action. The instance of action. That's but they did get similar amount of hits landed out of this. And the feature selections, seconds in the round, last action. Okay. So going back to the bottom, and then you have the Nunez test K-nearest neighbor results. Okay, so then going to decision trees, accuracy, and prediction. Nunez true results with predictions using Mazvidal's testing set. So it says how similar Nunez is, but to Mazvidal true hits landed. So Nunez's true results his in a decision tree is 80% accurate. And then testing set to Mazvidal testing set 41% accurate. And You can go through here and see the different variations with decision trees. So decision trees was used, and then ensemble, which used the logistic, Gaussian, high-base, random forest, and then it used hard voting for the best method. And Nunez's training and testing sets her model used on her own testing set is 81%. For the most part, naive is 47% for classification of hit planted. And then the Nunez testing set to train the model. So it's using the testing set, not the training set, to train the model. And then test on that testing set, it uses cross validation. So, yeah, 77 and 9 was 82%. And then Nunez testing set to train the model on Mazvidal's testing set. So, 80% logistic, 22 is 9 phase. So her 49 samples in her testing set was to train a model to predict on the 49 samples of Mazvidal's instances of it. And then the table, all this code, and so this is the ensemble predicted and the random forest predicted out of those 49 samples. Because it goes from 0 to 48 in Python. And logistic, negative phase, combines all of those. You can see all the results. This includes how many hits landed with 0 and how many predicted hits landed with 0, as well as how many predicted hits landed with 1 with true hits landed with 1. So the accuracy is not the same as if you just wanted to know what the true hits landed were equal to 1 and the predicted hits landed equal to 1. But this, and then PCA, that's just basically if you wanted to get rid of some of those features just without even removing some of them from that set that weren't necessary if you had like a huge data set. Principal component analysis will reduce those to the number of features you should use that make good, and it says around 20 out of 100. So you could use that, the neighbors equal 10, components good, pick 10 right in there somewhere. And then it shows principal component analysis with 1 and 2 components, the neighbors for k-means, and yeah, go through that, seeing different like training and testing sets. And you can see it goes from 0 to 2 because there were values in some of those instances where there were 2 hits, or 1 hit, or no hits for 0. And that can tell you that it ranges around closer to 1 to 2. And then, yeah, the k-means, what it averages by distance between points. The means, I think by default it's Euclidean, which is the standard distance. And running through, you can see the k-means where they cluster the classification. This is used for unsupervised learning if we didn't have all the feature details, just using those principal components. And then with cluster 3 for 0, 1, 2, this is the array that it uses for numeric values. And then you can see that you can predict on these arrays values using k-means, and you'll have the actual 49 results for hits landed, and then the predicted. It could be different for you, and if you didn't set the seed. And but again, you can get this information from Nunez and Mazvidal in Python at my GitHub here, Jan. And yeah, going back to that, you can see the K-means results 55% similarity of Nunez reactions to Mazvidal's actions. And then you have the actual predicted hits landed is 50% similarity. So not too bad. In similarity. And more kings, random forest right here, 81% accuracy, and this one is using just the model in general for training. This one's Nunez, and this is Nunez. So this is just her model accuracy. Planet is actually 81.4% with 100 trees. And then using this model that we just trained above on Nunez's instances with a different random state. Yeah, this one used 47 as a random state, and then 1. And the results, and this is on predicting not on her testing set, but how it predicts on classifying those hits landed in her model with cross validation. It pulls one out based on, I think the default 5. And then here it uses Nunez's testing set on our testing set, not the training set, so it models. It sees how well it classifies for 49 samples. Test on it with validation, 79.6% accuracy in her model. And then before that, training was 81%. And then this is going to actually use her training model, the one that was 81% accurate, on comparing it to Mazvidal's testing set. And these are the predicted results. This is her testing set model on Mazvidal's testing set. Those are the results. And if you wanted to see more on what the numeric value is in accuracy, we just combine them. I've lived in here at least twice. I thought this was an interesting project because it allowed displaying how to use some archery, but there's a lot of files in here if you want to go through it and improve it. Or I would like to use XGB on this file set too to add. It would be in Python. It would be to this script. I might have that later. Thank you. Right. Yeah, so you should try using this, or maybe you could even just screen some more of these instances that happened individually. I mean, just for like going through the screen sharing program, and I mean, just because I used a different screen saving film editor, and it would allow me to go into each second inside the file. I used Wondershare, so you should do that and see how accurate you get. It can take you a while. It's like 1 minute can take you like 20 to 40 minutes to write down everything if there's a lot going on. You have to like replay and not. And I think streaming, some of the stuff is choppy, so you don't really get every action. You have